Hello guys and welcome back. It's been a while, but we're back now. Today we're going to be doing the two sum problem, which is actually the first problem on Leetcode, and this problem is categorized as easy, which is really interesting. And I did this problem probably like 2 years ago, and I just recently tried to do it again and had some very interesting results. It says given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not choose the same element twice. So one thing that I would like you guys to pay attention to is when they say you may not choose the same element twice. Cause I actually skipped this bit when I did this problem, and yeah, my code didn't really give me the results that I wanted. So yeah, you may not choose the same element twice, and you can return the answer in any order. So they give us three examples. The first example has the input nums as being equal to an array which has 2, 7, 11, and 15 in that order, and the target is 9. And then the output is 0 and 1 because at index 0 we have 2 and at index 1 we have 7, as you can see. And if you add 2 and 7 you get 9. And then they explain the reason for the output. And then the example 2 has an input nums which is equal to 3, 2, and 4, and the target is 6, and the output is 1 and 2. So this example actually demonstrates their rule that says you may not choose the same element twice. Because if you think about it, if the target is 6, you could actually end up using 3 and 3 and then returning an array with 0 and 0, because they would give you the target which is 6, but that would be wrong. So you have to look for another number. And then the third example has nums 3 and 3 and the target is 6 and the output is 0 and 1. And this is correct because even though the value is the same, is 3 and 3, the indexes are different. So you're not choosing the same element because different positions means different elements, even if they have the same value at those positions. So our solution is going to be using a hash map, and I'm just going to explain how we are going to be using it. So basically our idea, what we want to do is that we want to have a map which is going to store the numbers, or let's just say the value at a position. Actually, let me use multi-line comments here to make it easy for me to write explanation. So it is going to use to store it is going to store the value at a position as the key in this map, and store the index for that value as the value in the map. So basically, let's say you have this array here, nums, which is equal to 2, 7, 11, and 15. This map is going to have a sample key as the key being equal to 2, and the value at that key, like in that map, is equal to 0, which is the index. That's what we're basically going to do. And then after that, we're going to iterate through the source array, which is nums source array, which is nums, and try to find the corresponding element that will make the total equal to target in the hash map. So if you don't understand like what I'm saying right now, don't worry. When I start writing the code, it's actually gonna make sense. So what we're going to do is we want a map with a key as an integer and a value as an integer. Let's just call it numbers or pairs or whatever you want, really, as long as you know what you're using it for. Let's call it numbers. And then what we're going to do is we want to populate this map with the numbers in this nums array and their positions. So we're going to say for int I is equal to 0 and I is less than nums.size and then I plus plus. And then what you're going to do is you're going to say numbers dot insert, and then you're going to put in a pair, of integers. The first one being the key, in this map, which is going to be nums I, and the second one being the position, which is I. And then after populating this, you're now going to be doing what we said, like now trying to find the corresponding element. So basically what we'll be doing is that you say for int I again is equal to, or we can use a different index if you want, not to confuse yourself, but it doesn't really matter. You can still use I because the scope is different. So for int I is equal to 0 and I is less than nums.size and I plus plus. You're now going to say if, let's say the value at a position, like we said, let's take an example of 2, 7, 11, and 15. This basically means that when this for loop runs for the first time, I is equal to 0, and the number at nums I is equal to 2. So what you want to say is you want to say if 2, right, which you have, and you're using it at that point in time, you want to look for 7. So you're basically going to say if target, which was 9 in that scenario here, if target, which is 9, minus nums I, which is 2, exists in this map, then you want to return the indices, the position of 2 and the position of the difference, which was 7, which is going to be 1 in this case. So you're going to say if numbers dot find numbers dot find target minus nums I is not equal to numbers dot end. So this basically means that the corresponding number exists. This is where now you have to be careful, because it says you may not choose the same element twice. So the number might exist because you populated the wall map here, and now you are going through the array again. So you need to make sure you protect yourself from using the same number. So what you do now is you put another conditional and say, and the indices are not the same. So you're basically going to say, and I is not equal to basically the value that is going to be at that position in the map. So and I is not equal to numbers, and then this is going to be a long line. Let's just press return, and I is not equal to numbers. Then you take the number, which is target minus nums I. So and the indices are not the same. Then you want to return a vector with those values. So a vector with I and the value at numbers target minus nums I, like this. And then, so because they said there's going to be exactly one solution, this means that all the sample or all the inputs that they're going to give you are going to have an answer, which basically means that this return statement is going to run all the time for this particular problem. But most compilers won't allow you to just write a function with no return statement that is accessible, like here outside. So we'll just say return, and then we'll just put an empty vector here, for safety purposes. So we might have made some errors, but we're just going to run this to see if it actually passes the first case and if there's any syntactical errors that we need to fix. So we're going to run the code. And then it says too many arguments to function call. Okay, so for int I is equal to 0 and I is less than nums.size. Oh yeah, here the size function does not take a number. So that's I forgot that, made a mistake. So now we run code, and then it basically passes this first case. So now we need to see if it will actually pass the rest of the cases. And I'm pretty confident that our algorithm makes sense. So we'll see if it actually passes. If it doesn't, we'll go through it and see, you know, where we're going wrong. And then yeah. So yeah, as you can see, it passes all the test cases. So obviously there are many adjustments that you can make to this solution to make it actually more faster. But the good thing is that, you know, this follow up here that says, can you come up with an algorithm that is less than O of n squared time complexity? This algorithm that we have here is actually less than O of n squared time complexity. The only thing is that we're using a lot of memory by using the map, but with a few refinements and adjustments, this algorithm will just will run faster and faster. So yeah, this is how you solve the two-sum problem on Leetcode with a time complexity of less than O of n squared. Thank you guys for watching. For more videos like this, do not forget to like and subscribe, and see you in the next video.